So hello guys, this one is the analog question for the OA from the Texas Instrument. So in this question, op amp is given and we have input current. This is the injecting input current. So in this, what we can say, we have to upload the Vout and VC graph on this axis. Okay. So first, nothing is mentioned. So it's an ideal op amp. And for the ideal op amp, and we can say it's this is in a negative feedback system, so we can say we can apply a virtual short we can apply. If we apply a virtual short here, then this voltage is also zero, and for this time period from 0 to t1, as this one is t1 time period, we can say it nothing, no current will pass through, so the voltage drop across the resistor and capacitor is 0, so this Vout is also 0, we can say. So uh, for the analysis part, now we have to do analysis when t is greater than t1. When t is greater than t1, we can see the input frequency is infinite. As input frequency is infinite, as input frequency is infinite, then 1 upon SC will become 0. So the impedance of the capacitor will become short. It will behave like a short circuit. So the capacitance impedance will become short circuit, and the for t greater than t is equals to t plus time, we can say Vout is also 0. Okay. But now uh, if let's assume that t1 minus t2 time period is less than tau time period. We are assuming this condition. Tau time period means the capacitor will not charge fully and not discharge fully in t1 to t2 time period. Okay. So as time moves from t1 to t2, as time moves, we can say capacitance. What we can say, we can say the impedance of capacitor are start increasing. uh, like at t1 its impedance is 0, but at t2 its impedance is something, some value ZC, we can say. So we can say that impedance of the capacitors are increasing, so the overall impedance of this branch is increasing. As as at t is equals to t1, t is equals to t1, if I am representing the overall impedance of this branch is z0. At t1 the z0 is at t1 z0 is 0, and at t2 that z0 is something, like z0 is something can z. So we can say at t1 to t2 the impedance of this capacity is this overall branch is also increasing. So now the conclusion is this: when a current is injected, no current is flowing in this terminal. So some current will flow in capacitor branch, and some current will flow in the resistive branch. As some current will flow in the capacitor, it its voltage start rising. So capacitor voltage start rising. But the thing is, what we can say, how the capacitor voltage rise, how capacitor voltage rise, like it's increasing linearly like a ramp, or increasing exponentially, or increasing quadratically. What we can say? So in this, we can say the given current is like a step voltage from or a step current from T1 to T2, but the impedance of ZC are continuously increasing from T1 to T2. So the current distribution of IC, we can say IC, and the current distribution of IR, sorry, current of IC and IR are changing continuously as time increasing from T1 to T2. So as current is continuously changing in the capacitor branch, so the voltage rise in the capacitor will like exponential. When will the ramp voltage occur? Ramp voltage occur when the capacitance when the input current of the capacitor is like a ramp. But we can say that we can say by the current distribution that IC is continuously changing, so the voltage rise in the capacitor is like exponential. And when will it rise like a parabolic, when the current is when the current is like ramp. In this case, the current in this when is the ramp voltage when the current is like a step current, and when is the current is the parabolic form when the current is variable, a changing continuously changing current, or when is the current become parabolically, and the changing current is IC. This is the ramp current. Okay. So in our case, the current is changing, so we can say that the our voltage in the capacitor is like in this manner. So now we are in our final part of this question. So the capacitor voltage like rising like this exponentially, and so the same for the resistor, as these two are in our parallel. And what we can say also, that what is the relationship between the input current or output current, like if we assume this voltage VC, and it current is entering in this node, so this terminal is positive and this terminal is negative. So the output voltage Vout is dependent on, as if this is plus side and this is minus side, so Vout is negative, which is negative of IC. We can say IC is we are achieving by the current distribution of this I in. So IC has some relationship between the I in and IC into V out. This is the relationship. So we can say the output voltage is negative, as this negative voltage is shown by this negative current negative sequence, and the IC has a relationship between I in R on R plus SC. So this is our IC. This is IC. We can put it here. So now if we make a waveform, if we first let's analyze the second part of the circuit. In the second part, when t greater than t2, t greater than t2, the current I in, which is becomes zero, but we can say there is some finite voltage on the capacitor. Finite voltage V dash. Let's suppose, let's tell this a V dash. We have some finite voltage appearing on the capacitor. Now if we make a circuit like this, this is the circuit. This is plus minus, and our resistance is connected in the parallel, and it is connected to the V out node, and it is ground, as this is the AC ground of the circuit, and the capacitor has some voltage V dash. Now we can say that the capacitor is saying a parallel resistance R, and it will start discharging its voltage through the R resistance. So when T greater than T2, the capacitor start discharging, and it will discharge all its current in this resistor R and the final voltage when T tending to infinite will become when T tending to infinite will become zero. So are you getting my point? Like if we plot this on the if we plot this on the graph, like this is our in. First, I am plotting in. This is our in. In is from T1 to T2, and this is T1. This is T2. Uh, this is V. See capacitor voltage, and capacitor voltage is like this. Capacitor voltage when in this time period, in this time frame, the capacitor voltage is zero, but when we hit T1, capacitor voltage start rising exponentially. So it's rise exponentially like this. But whenever when we hit T2, it capacitor start discharging like this. So you can see like this is the voltage waveform for this capacitor. But if we plot output voltage, we have to plot output voltage. Output voltage is the opposite of this capacitor voltage. So it will look like this. This is our zero. This is our V out voltage, and it act it look like this. First it will reach the minus V dash. This is our V dash. This is minus V dash. And now when time hit minus infinite, it will become like this. So this is our final solution for this circuit. So hope you like it.